Hello friends, myself Venugopal Panchumarthi. Okay, so I had released two videos based on sorting, part 1 and part 2. So in part 1, I had discussed about bubble sort, selection sort and insertion sort. And second part, I have discussed about quick sort and mid sort, right? Okay, so in this video, we are going to see how we are going to build them, like a kind of visualizer, I would say. Okay, so let me share my screen. Hope you can see my screen. Okay, so before seeing this, how you are going to building this, interactive sorting visualizer. So first, let me quickly summarize all these five algorithms that we have seen so far. Okay, let me give a quick summary of all the five. Okay, so first three. So these three we have seen already in the part 1. In case if you haven't seen, so please go on. It's already available in the channel. So this I have discussed in the part 1. Okay. Then these two I have discussed in the part 2. So part 2 I have discussed. Now this is continuation for that, which is part 3. Okay, so this is part 2. Right. So generally, what is objective of any sorting algorithm? So you need to sort it, right? Either it is in the non-increasing order or in the non-decreasing order, or maybe people will call either increasing or in the decreasing. Okay, so here it's simple two arrays I have taken. One is it's a random order. So this is. Now, if you see, these elements are already in the sorted order. These elements already in the sorted order. If I give this input to any one of the sorting algorithm, so what will happen? Similarly, I have taken one more input array. So this is a random order, which means it is not sorted. Okay. Now, if I give these kind of inputs to any one of these 5 sorting algorithms, how these will behave? Let me quickly explain all this. Okay. So first, let's talk about the bubble sort. Okay, so what is the idea of the bubble sort? So let me take this input array. I'll quickly explain the idea behind the bubble sort. So generally, we are going to compare. So basically, this bubble sort will run on passes, right? So in the first pass, what will happen? So we are going to compare these two elements. If they are not in the proper order, which means they are in out of order. So 7,2 is not a proper order. So proper order will be 2,7, right? Because we want to sort it in the increasing order. So therefore, you need to swap. So which means if I swap, what will happen? So 2 will be coming, 7 will be coming. Next, when you compare 7,1, again they are not in the proper order. So you need to swap. So then 1 and 7. Again, when you compare 7,9, yes, they are in the proper order. Next, when you compare 9,5, so they are not in the proper order. So you need to swap, which means 5,9. So with this, the first pass is completed. Similarly, what about the second pass? Again, same thing will be continued, right? Okay, so again start doing 2,1, not in proper order. So swap 1 to 2,7. Yes, they are in proper order. Swap is not required. Then 7,5, they are not in the proper order. So swap is required. So 7. And okay, if you compare 7,9, so swap is not required. Now we have seen one observation in the bubble sort. That is, the first maximum will be coming to at the end, right? At the end of the P1, which means first pass, whatever the first maximum will be coming here. Similarly, at the end of the second pass, second maximum will be coming here from last to second position. Third time, so third maximum. So here, just in 2 passes only array got sorted. But in general, n-1 passes we need to conduct. Okay, so here we are so lucky that this input got in 2 passes only it is got sorted. Okay, so what is the time complexity for this bubble sort? So time complexities depends upon 2 things. One is here we are doing 2 things, friends. That is, comparisons we are performing. Similarly, swapping also we are performing. Okay, so the time complexity depends upon number of comparisons that you are doing and plus number of swappings that you are doing, number of swaps you are doing. Okay, so worst case, how many comparisons will happen in terms of big O, or approximately how many comparisons? If you give a reverse sorted array, right, which means all elements are, let's say, in the decreasing order and you want to sort it in the increasing order, then in such case, the worst case you will be getting n square comparisons. Okay, what about swaps? Similarly, whenever if the comparison true, then swap will obviously takes place. So swaps also, see, this is not exact swaps. So let me put this is in terms of big O. Similarly, swaps also big O of n square. So what is its time complexity? So order of n square in the worst case. This is the worst case. Okay, what about best case? Best case input, which means algorithm should take minimum amount of time. Such kind of inputs, we call it as a best case inputs. Okay, So what is the best case input? For example, if all elements are in the sorted order, if I give, then also this will take n square time. But we have modified this bubble sort. What modification that we have kept? See, in the first pass, for example, not in the first pass, in any pass, if you found out that part of the array or complete array, if it is sorted, then we are basically skipping the subsequent passes, which means we are breaking the remaining passes. Why? If array is sorted, why to connect the remaining passes? Got it now? So which means first pass will be running. So n comparisons will happen, order of. After that, if array is really sorted, then 0 swaps will be happening, which means in the constant. Then in the next iteration, if you see, we have declared a Boolean flag. I think in the first iteration itself, this loop will break. So therefore, there its a time complexity will be order of n. Order of n. Okay. See, this is when, friends, it is in the worst case. This is when this is the best case. Best case. Okay. So this is the idea of the bubble sort, right? Okay. Now let me go to the next sorting algorithm, that is selection sort algorithm. So we have seen the bubble sort, and this is the overall idea of the bubble sort. Okay. If you want the detailed analysis, you please watch that video. In the part 1, I have clearly discussed about this. Next, second sorting algorithm, that is selection sort algorithm. Okay. See, selection sort is very simple, friends. So let me take this input. Okay. So what is the idea of the selection sort? Simple. So you first take this element first. Okay. So you divide this array like this. Now you can take I is here, including this element. In the remaining array, you just see where did you got the minimum element, including this. Okay, na? Including this. So let's say I found out that in the first pass, the minimum element is presented here. So you have taken this, I is at here, and you found out that minimum element is here. Now what you are going to do? You simply swap these two. So if I swap these two, what will happen? So 1 will be coming here, and 7 will be coming here, and the rest of the elements will stay as it is. Okay. Now the first pass is completed. The first smallest element came to in its correct position in the final sorted array. Okay. Similarly, continue the same process till last before element. Now take this element. Okay. Then including this, you check where did you got the next minimum. I think if I is here, minimum element also here. When I comma minimum is pointing here, swap is not required, right? So at the end of the second iteration, so 1 will be here and 2 will be here, and the remaining elements as it is. Okay. So in the first two passes, first two elements came to their proper positions. Same process you need to conduct. That is, if I is now at the third element, now including this element, you please check where did you find out the next smallest. I think here we are so lucky that at the end of the first pass only, in fact, we got the sorted array. But unlike bubble sort, here we are not having any mechanism to check array is sorted or not. Whereas in the bubble sort, the story will be different. So at every pass, we can check that array is sorted or not. But in selection sort, it is not the case. Okay. So you need to conduct all the passes. So this is the idea, friends. Again, let's see what is it's a time complex. So again, if you see, friends, here the time complexity depends upon two things. One is again comparison, and again swapping. Okay. The two, but here one important observation that you need to make is, so this is comparison, this is comparisons, this is swapping, okay, this is swapping. So time complexity depends upon number of comparisons plus number of swaps. Now if you see carefully here, these, where did you write this swap line? If you check, that is outside of this for loop. This for loop is there na? Outside of this for loop, basically you have written this. Therefore, whether it is, if it is a worst case, then only n swaps will happen. See, I'm talking about worst case input, friends. I'm talking about worst case input. So worst case, n swaps will happen. Why? Because in bubble sort, swap you have written inside this for loop. So that's why n square times these comparisons are happening. How many times these comparisons are true? Those many times swaps are happening. Whereas in the selection sort, that is not like that, friends. In the selection sort, at the end of this for loop, basically you are writing a swap condition. Getting na? So you are not writing inside this for loop. Outside this for loop you are running. Therefore, worst case, how many times this loop is running? Those many times only this swap will happen. Not those many times. This condition also has to be true. But assume at every ith iteration, assuming that this condition is true, then swap is happening. So n swaps will happen here. N swaps will happen. What about comparisons? We have seen the swaps. What about comparisons? Let's say worst case n square comparisons can happen because inside this for loop, these comparisons you are writing, right? Therefore, here n square comparisons can happen in the worst case. Therefore, what is its time complexity? So its time complexity will be n square plus n. See, this is may not be the exact comparisons. This is in big O. So n square plus n. So the dominating term is n square. So the worst case time complexity of the selection sort is order of n square. Okay, na? Now, what about best case? Let me tell you. So we will take best case input, friends. That is, maybe all elements are sorted. So let's say 1, 2, 3, 4, 5. So let me take all elements are in the increasing order. Now see. So including this element, okay, when I is at here, including this, you need to check this. Where did you find the minimum element? Which means 1, 2, 3, 4 comparisons are happening. Okay. But you found out that minimum and I both will point here only. So swap will not happen. Okay. Next, if I moves here, including 2, where did you find out the minimum? So you need to compare. So 3 comparisons will be happening. Like that, 2 comparisons, then 1 comparison. So if n is equal to 5, you can identify some pattern. This is sum of the first n minus 1 natural numbers. So which is nothing but n into n minus 1 by 2 in general. So which is again n square comparisons order of. So though it is the best case, see here carefully, I am talking about best case. So n square comparisons will happen plus 0 swaps will happen. So 0 swaps will happen because in the best case. So it is in terms of big O. So again it is n square. So for the best case input, bubble sort is better compared to selection sort. Bubble sort is better, friends. Though worst case it is giving n square, best case also it is giving order of n square. Now if you see in bubble sort, the best case it is taking n and worst case it is taking n square. Okay. Now in the interview, maybe one question is possible, friends. Okay, whether it is bubble sort or selection sort, if you want to get less number of swaps, see sometimes swap operation might cost. Okay, compared to comparison operator, sometimes swap operation is more costly. So no matter what type of input that I give, if I want to do, okay, in less number of swaps, okay, I can give any type of input, maybe best case input or worst case input, but I want to do sorting in less number of swaps. Then can you tell me which algorithm will you prefer? Less number of swaps. Let's say always I am giving worst case input. Then which one will you prefer? There n square swaps, here n swaps. Worst case n swaps. Therefore, selection sort is better. Okay. But overall time complexity, obviously bubble sort is better overall. But if I want to do it in less number of swaps, okay, because here n swaps only happening. Right? So this is the story about selection sort, friends. Okay. Now let's go and talk about insertion sort. Okay, so third one, it's a very beautiful algorithm, insertion sort. Okay, so what is the idea of the insertion sort? Very simple. So let me take one example. So maybe example is 4, 2, 1, 3, okay, 5, and maybe I will take 6. So let's say, okay, let me take 7. Let's say this is the input array that is given to me. Okay, this is the input array that is given to me, right? Okay, now first element you just leave it. So in insertion sort, the idea will be, we will assume always the left part is sorted, right part is unsorted. That is how we will assume. Okay, I am assuming that this part is always sorted because when you have only one element, so it's always sorted. Now the story will start from here. Okay, story will start from here, from the second element onwards. That's why if you see here in the loop also, I have started I is equal to 1 because indices are starting from 0. Okay, now what I'm going to check. So I will try to find out in the final sorted array where this 2 will go. Okay, so these two I will compare with all its left side elements. Then when I go and compare, I found out that, okay, so 4 is bigger than 2, which means this 4 should not be the right position to sit here, because 2 is smaller now. So when I'm having a smaller element, then definitely I will push this element to somewhere else and I will put it here. It's a kind of, when we play a cards game, let's say you take 10 cards, you want to arrange all these 10 cards in a proper order. So how we will do? So in one hand you will pick all the cards, then we will move, right? Something like this. So we'll compare with one card and let's move that, something like that. Okay, so now what we will do, I will move this 4 here, which means now 4 will be coming. But you will be thinking that this 2 will be overwritten by 4. Then are you not going to loss of 2? No. This 2, we will store it in a variable called as key. We will store this variable called as key. We will store this 2. Okay, then I have moved this 4. Next, is there anything else here? Nothing. So now happily I will put this 2 here. So what will happen? So this 2 will be coming here. 2 will be coming here. Okay, remaining elements will be like this: 1, 3, 5, 7. Now first 2 elements are done, friends. First 2 elements are done. Next, I am going to pick this element. Now I will be going to the next position. Okay, I will be here. Now again, I will compare 1 with 4. Okay, I will check. Is 4 is right person to sit here? No, because I have a 1. I am smaller than you. So how can you sit here? You cannot sit here. Therefore, I will throw this 4 at here, which means this 4 will be now overwritten by 1. Okay, this 1 will be overwritten by 4. But you might be thinking that, what about 1? Am I not going to lose this 1? No, there is one variable called as key. In that key, basically, you are storing this 1. Okay, now then again, now compare this 1 with 2. Now are you, see, do you have any right to sit here? No, because I am smaller than you. In the final array, I will be coming before you. Therefore, okay, you should go somewhere else. So it will throw it here. So it will throw it here. Okay, then next, is there any element here? No, therefore you can now place this 1 here. You can place this 1 here. So at the end of this, what did you got? 1, 2, 4. Okay, these 3 are done. Now 3, 5, 7. Next 3, 5, 7. Okay, now again start the same thing. Now you take key is equal to 3. Okay, now compare. So okay, 4 is right to sit? No, because if you found any smaller element, then this has no right to sit here. So push it to the next position. So let's push here. But don't worry, 3 is present here. Okay, now again, now compare 3 with 2. Now 2 has right to sit here. Yes, 2 has a right to sit. Why? Because 2 is smaller than 3. Therefore 2 has a right. Since 2 has a right than 3, now can I stop the procedure? No, maybe sometimes what can happen here, you found out that 3 is bigger, so you might be stopping. But let's continue the procedure. Now again I will check. 3 will ask, hey, do you have a right to sit here? It will say that yes, I have a right. But here itself it will stop. Here itself it will stop. So this 3 will be updated now. Then what will happen? 1, 2, 3, 4. Okay. This is sorted. This is sorted. Okay, here I told it's wrong, friends. So it will stop it. Now, okay, now see here, you will be getting 5. Now, we are always assuming that this part is sorted, right? That is our initial assumption. Now, when you compare these 5 with 4, 4 is saying that I am smaller than you. Since this array is already sorted, then definitely these values will be smaller than 4, because that is initial assumption is every time we are thinking that array is sorted in the left part always. Therefore, this will stop. That is why if you see in this condition also, I am writing this, right? Okay, so this is how the insertion sort will work, friends. Okay, now let me find out. It's a time complexity. Let me explain. It's a time complexity. Okay, now I'll remove everything. Again, we will take 2 type of inputs. One is best case input. Second is worst case input. We will take. First, let's take about worst case input. Okay, so I will take all elements in the decreasing order. Let's say 7, 6, 5, 4. Okay, 3, 2, 1. So number of elements are here equal to 7. Okay, now let's see, friends. So if you remember in the part 1, I have discussed something about insertion. Something called not insertion, inversion. Inversion. What is the definition of the inversion? Take any 2 distinct array elements such that these 2 should be different, I less than j, and array of I should be bigger compared to array of j. So this is called as inversion. Correct? Okay. Now, what is the story of insertion sort? These 6 will be compared with this. This 6 will be compared. Okay. See here in the insertion sort, time complexity depends upon two things. One is comparison, second is movements. So it is depends upon comparison plus movements. Okay. Comparison and movements. Now check, 6 will be compared with 7. Okay. So only one comparison happened. They are not in the proper order. So this 7 will become here. So one movement is happening. Here, one comparison happened and one movement happened. Next. Okay, then 6 and 7 will be here. Now when I is at here, okay, then again this will be compared. So they are not in the proper order. So movement will happen. Next, again this will be compared. So they are not in the proper order. Movement will happen. So here 2 comparisons happening and 2 movements are happening. Similarly, next here if you check, basically these all are actually the inversions to this 4. That is what I am trying to say. Right? So like this if you continue, so there are worst case n square comparisons are possible and n square movements will happen. Okay, n square movement will happen. That is why in worst case its time complexity is order of n square. Okay, so if you take any worst case input, so the number of inversions will be order of n square. Order of n square inversions are possible. When n square inversions are happening, then those many comparisons will happen. Since every comparison is not proper order, so movement will happen. Okay, this is the worst case input. Then let me take the best case input. When all elements are in the sorted order. Now check. So these 2 will be now compared with 1. Proper order. So one comparison only happened. Next, when you compared 3 with 2, okay, right, this is small. So while loop will fail. Then again, outer loop, okay, I loop. When 4 is compared with 3, this condition will fail. Then when you compared with this, comparison happened, this condition will fail. Again, I value will come here. So if you see, these here, how many comparisons are happening? Only n comparisons are happening and any movements are required? No movements are required. Therefore, zero movements. So are you getting the friends? So here, the best case time complexity will be order of n. So comparisons, okay, and 0 movements, so order of n. So if you see in the best case input, how many inversions are possible? So number of inversions, 0. Again, if you are not understanding what this inversion and all, you need to watch the previous video. Then only you will get to know. This is a quick summary only. 0 inversions. So if you observe carefully, friends, in the insertion sort, time complexity is purely depending upon how many inversions are there. Here n square, here it is 0. Therefore, which is bigger? Bigger is n square. Okay, let me take D. Okay, let's say D is number of inversions. So here n square comparisons, n comparisons, I will take the minimum one and I will write order of n plus D. Now for example, let's say here worst case input if you give, then what will be the inversions in the worst case? N square, right? So this D will be n square. So n plus n square, overall it is order of n square. Okay. If you provide the best case input, 0 inversions are there. So this n square will become 0, which is constant time. N plus 0, it will become order of n. So matching, right? These both. So therefore, generally people will represent insertion sort time complexity is order of n plus D, where D represent number of inversions. So depends on what type of input. So if best case input, time will be n. Why? Because no inversion. Whereas if you give worst case input, n plus n square, because n square inversions are there, whichever is maximum, that we will take. So order of n square, right? Okay, because D is equal to 0 here and D is equal to n square here, right? So this is the story of the insertion sort. Okay, right. Now next, let me explain about the merge sort. So these 3 I have covered it in a part 1 at great detail, right? Now let me talk about the merge sort first. Okay, so in merge sort, basically it works based on the divide and conquer technique, right? So this merge sort will work based on divide and conquer. divide and conquer. Right? Okay, so we will take the bigger array, we will divide it into smallest arrays that is possible. So maybe if I'll take element 7, 2, 1, 3, 4. So what is the story? So first we will divide it into two parts. Okay, so we will divide this array into two parts, 7, 2, 1, then 3, 4, 9. Then again we will divide this into two parts. So let's say 7, 2, 1. Then we'll divide here 3, 4, and 9. Next we will further divide it till you will get only one element we will divide. Okay, so this will be 3. So 3, 4, and 9. Once it is done, then once this division was over, now we will apply merge procedure. So we will apply the merge procedure. So merge procedure, always input will be sorted array. Two sorted arrays will be given to the merge procedure and the merge will happen. So merge will be happen here and there. Then we will get here 2, 7, and this will be 1. Now merge procedure will happen here. Then output will be 1, 2, 7. Similarly here also, this is 3, 4, 9, and merge procedure will happen 3, 4, 9. Finally merge procedure will happen here on the two sorted arrays. Okay, so you will be getting finally 1, 2, 3, 4, 7, 9. So final sorted array. So this is how the merge sort will work, friends. So since this is only summary video, so for the full detail video if you want, please refer the part 2. Okay, now we have even seen its time complexity also, right? Okay, so assume if n elements are there, so I have written the recurrence relation in that video. So T of n is equal to, let's say T of n represent time to solve n elements using merge sort. Then what is the relation? So first you are doing a dividing, right? So 2 times happening with size n by 2 exactly. So 2t n by 2 plus the merge procedure itself is taking n time. So n. This is when you have at least two elements. Let's say if you have only one element in the array, then constant time is required. So let me take that constant time as 1. So this is the recurrence relation for the merge sort. Okay, and I have even shown its proof also. So using back substitution method, I have explained. So time complexity as order of n log n. Okay, please refer that video for the proof. What about space complexity of the merge sort? So merge procedure will require two sorted arrays, right? Every time. So we need to create two sort arrays and you need to push those elements to the arrays. At last level, if you take, here you require size of n by 2 array, here also you require size of n by 2. So overall, the space complexity, see, this is the time complexity. What about space complexity? So which is order of n, because it requires extra array to sort it. So space complexity will be order of n. Whenever space complexity is not order of n, not order of 1, we call such type of sorting algorithms are not in place sorting algorithms. In place means space should be order of 1, constant amount of time. So here if you see space is not in constants, right? So it is taking order of n. So merge sort is not in place algorithm. Okay, please remember, friends. So this is the story behind the merge sort. So here I have shown the merge procedure also. You can go through that video and you can watch this. Okay, next we will be having quick sort. So for the merge sort, merge procedure is hard. Similarly, for the quick sort, okay, so the heart will be something called as a partition procedure. So partition procedure. Partition procedure. Okay. So basically, partition procedure have many implementations, friends. In the two popular implementations are, one is Lomuto's partition scheme. Second is we have Horace's partition scheme. Two different partitions. These are the two popular ones. Again, you can also come up with your own partition scheme. No problem in that. Okay. So here in merge sort, if you remember, friends, the array exactly we are dividing into half. Every time it's n by 2 elements, n by 2 elements. In this n by 2, half of it, n by 4, n by 4. So almost every time we are dividing array into equal sizes, and after that we are applying the merge procedure on it. But in the quick sort, it is not like that. In the quick sort, the division will be based on the index value that is written by the partition procedure. Sometimes partition procedure might return exactly middle element. Okay, then so let's say when it is possible, for example, let's say we have some elements in the array. So we have some elements in the array. Let me take. I'll take one input array here. So some elements are present. So let's not worry what those elements are. Okay. So generally, last element will be chosen as a pivot. So this element will be chosen as a pivot. So what quicksort will do after the first completion of this partition procedure? So it will find out where this pivot element should present in this array. So that it will try to find out. In fact, if you choose median of the array as a pivot, listen carefully, friends. This is median. Median element of the array. If you choose as a pivot, see what is meant by median element. Generally, what is the meaning of median? Simple. Some elements are there. Let's say you have 7, 1, 2, 5, 4, 3. Okay, let me take odd number of elements. Here in these elements, okay, let's say list of elements. What is median here? Simple. You sort it. If I sort it 1, 2, then 4, 5, 7. Then this middle element, we call it as a median. So the middle element, we'll call it as a median. Correct, na? So therefore, last element you are choosing pivot. The chosen element is, let's say, median. Then at the end of the partition procedure, what will happen? So we are going to place this pivot such a way that all its left side should be smaller than this pivot. Let me take less than or equal to x. All its right should be greater than or equal to x. Okay. If no duplicates, you can remove equal to symbols. Actually, one side only we should put this, such that this partition procedure will make this array. Then, since it is middle element, how many elements are present? More or less, those many elements will be present here also. Right? So exactly n by 2 elements and n by 2 elements, and partition procedure will take n time. So what is the total time? So t of n is equal to n plus t of n by 2. T of n by 2, where n is greater than or equal to 2. But if you have only one element, in fact, no sorting algorithm is required, constant time. So this is more or less similar to merge sort, right? So the time complexity will be order of n log n, right? But what if the chosen element, pivot element, if you choose and it is not a median, let's say. Sometimes what can happen, you choose any element as a pivot that can divide your array into something like, so let's say here, input array we are having, okay, some elements are there. You have chosen the pivot element. Two cases are possible. Case 1 is, it can divide your array elements into n minus 1 into 1. This is one possibility. Or maybe it can divide one element like this, n minus 1 elements other side. So in both cases, if you see, the recurrence relation should something like this. So t of n is equal to, so n plus t of n minus 1. This is when n is greater than or equal to 2. So constant time if number of elements are equal to 1. See, I think you might be not understanding since if you watch directly this video. So in my part 2 video in quicksort, I have clearly explained about these two cases. In when this case is possible, in when this case is possible. Okay. So here, if you solve this is order of n square. So if you are not understanding, since it's a summary video, you please watch that one. Watch that one. Okay. So order of n square. And I have told you three cases where these kind of scenario is possible. All elements are in the increasing order, or all elements are in the decreasing order, or if all elements are equal. So these cases, quicksort behave very worstly. So order of n square will give the time complexity. Now we have something called randomized quicksort. Though if you use randomized quicksort, on an average case you can reduce time, but worst case you cannot. Okay, it is order of n square only. Right? So these two partition procedure, one is Lomoto's partition scheme and second is Fourier's partition scheme. Okay, so this is the complete summary of the 5 sorting algorithms, friends. Right? Okay, so now I'm stopping here and I'm going to take this. Okay, now I'm going to stop it here. Now one of my colleague Aditya will be taking from here and he will be showing how actually you need to visualize, what tech stack is required and how you are going to build these kind of visualizers. So these things my colleague Aditya will be explaining. Okay, yeah, thank you, friends.
So hey guys, so now you are very much comfortable in every sorting algorithm, I guess, right? So basically, you have practiced it a lot. Now, also you have revised it. Venu, thank you for the informative session on the sorting algorithms. Now let's take the step and discuss how to build a visualizer to visualize these sorting algorithms in a much better fashion, right? You can visualize these things like when you had taught you, right, through dry run. Uh, but if there is an application which shows you this steps uh, through an animation, a simple animation, that would be great, right? So basically, hi guys. So I'm Aditya. I'm a curriculum engineer here at Masai. So I'll be explaining how to build a sorting algorithm visualizer. Okay. So now at the end of the day, like once we have completed this session, what will you be able to build basically? So this is the application that I will be showing you how to build. I will walk you through the code. I will walk you through the logic that how you will approach things, like how you think how to visualize things, right? How will you think like what all components I need, right? So basically, first of all, I will tour you basically through this application, how this application works, and what all you can expect from this application, what all things you can build. Okay, so basically, this is a visualizer, right? So here you can select any sorting algorithm. Like for example, I have selected bubble sort. Here you can select basically like speed if you need faster, slide it down, right? There are two different types of inputs. Right, basically you can take input as an array length, or you can take input as an array separated by space. Both works completely fine. You can take input as it is, like it will be visible at the same moment. And so for now I'll be taking as a length, random length. Suppose I take a random length of 40. So basically after this, you can, first of all, you will have to sort it, right? So once you have clicked on the sort button, you will have two options, right? First option is that you can visualize step by step. Once you click on the step, it will move one step forward. Then if you again click on the step, it will move again one step forward, right? And if you want to visualize it automatically, like if you want this to visualize like in a, like you don't want to step by step, like you want to visualize in an animation format, like what is the end, what is the process it has gone through, you can directly click on this visualize button. Now how to toggle between these steps and visualize, basically this is, if you want to go step by step, like just click on this step by step, this will be visible. Now you can click on this steps. Now if you click on this step basically, so it will show you different steps of bubble sort, like two elements have been started comparing with each other, like if they are not fit at their place, like they are getting swapped. Now this color combination has been mentioned here, like which represent what, like for example red represents compare, blue represents swap, green represents sorted. If it is sorted, it will be at the sorted position. And this minimum yellow required, that will be for your selection sort. If you apply selection sort, you will have to find a minimum element, so there it will be helpful for you. So basically now if I go sort step by step, I will be moving a little bit faster. So once you go to the end, so now in bubble sort, what happens, the largest element start pushing to the end, right? So once it reaches the end, that means this last element is at the correct position, so it is sorted. Now it will be in the green color, right? Now again the step will start same, it will go ahead. Now if I want to visualize it automatically, like I don't want to click a step by step, okay, so what you can do, just reset it first. If you don't reset it, it will not you will have to, you want to get a new array, right? So you can enter array as the way you want, like let me make it a little faster. Okay, so if you put it like let's say 40. Okay, let's put it faster. First of all, you will have to let me not that fast. So let's this time let's select selection sort. Okay. Now first of all, you will have to sort it. Then by default it is auto visualize mode. Once you click on this visualize, what will happen? It will visualize. It will show you an animation, same step by step, it will play as a movie, right? Automatically. So let me click on this visualize. So basically, if you can see, this yellow element is the minimum element throughout the loop, and one by one, if it is getting sorted, now you can see things are getting sorted, and the position of the element which is at the sorted place is in green color. Similarly, it will go throughout the process, and one by one, the elements will start sorting. So in this manner, you can visualize things. Now you might be wondering how to build this application. Believe me, building this application is pretty easy. If you know like how to write sorting algorithm, if you are aware about front-end tech stacks, right? Using basic HTML, CSS, and JavaScript also you can make. But here I will be using React, right? Basically. So now we'll be looking into how to think before we jump into code, right? So now at the end of this video, like I'll be explaining you through the code, like how I built it, what are the different components, how the different components are working with each other, right? Now we need to be aware about the tech stack. Like either you can use HTML, CSS, JavaScript as a vanilla JS as well, like basically. But here I have used React JS, right, to create this application. So basically, now how to visualize this thing. The question comes in how to visualize. Basically, you know the sorting algorithm, right? You know how to create a front-end application also, right? But the question comes in how to visualize. If you write a sorting algorithm, what happens generally? The moment you click on this button, it gets sorted. You will get the sorted element quickly. It won't take much time. Like if it is a small array, like maybe 50, 60 elements, even 57, 100 elements, it will be sorted automatically, like in a millisecond of time. But how will I visualize this thing, right? So you might be wondering, I can slow down the process. That is also a way, like that can be done. But there is a better way that I came up with. Like, for example, here I'll be taking example of sorting, bubble sort, right? So if you can see the steps one by one, like these are the steps that are involved, right? Two elements get started comparing, and if they don't fit at their place, they swap with each other. So these are the steps that is involved there, right? So basically, how we can make this a step, like to play as a movie, how can I control the speed? Basically, this should be showing as an animation, this should be showing as a visualizing thing, right? How can I make this thing? So we will look into it, how to make up your mind basically to think accordingly. How can I create an application to visualize this thing? So I will tell you, basically I will tell you how to visualize things, how to, before coding, like your mind should be prepared, like how should I approach it, right? Before coding, just take a pen and paper, just do a lot of rough work. I generally do. So basically, in bubble sort example, like this example, you already know this is the kind of dry run of a single pass, right? Now what happens basically, the color combination you see little different that I have used in the application, but this blue color is what when it comes to a sorted position, right? So now when let's come back here. So the question is, have you seen old day movies? Like I'm 100% sure that you might have heard about at least how old days movies used to come, right? They used to come in form of reels, right? There used to be like negatives kind of thing, and these were wrapped into a rotator, and it used to rotate at particular basically speed, and that moving basically a rotator, it felt like a projection, felt like the pictures the person is moving, like that kind of movie that used to come in old days, right? So similar kind of approach we will be looking into uh, creating this visualizer, right? Now if I want you guys to pause this video for a moment and think basically why I'm telling you this example of this old days movies, like this reels, this negative, like how can I use this? Okay, so if you have thought of this thing, that's great, but if you have not, I will tell you how. So if you go back, if let us go back to the bubble sort example. Okay, Now the same example that you took, that I took, basically the real example. Now, if you imagine the dry run of a bubble shot, can I say that array gets converted from a particular stage one by one, right? Suppose in this first state, it is the state of this array is this thing. In the second stage, the state of this array is this thing. Third state is this thing. Can we consider it this all these states as a real kind of thing, similar to our movies, similar to our movies, and we can play it like basically whenever the sorting is working, whenever you are sorting, like for example, initially the state of this array is original array, then after a single loop, uh, this array got converted to this array. Now which all elements got swapped, I will store it that as well, right? Which all elements got compared, I will store that as well. Which all elements got sorted already and are at the sorted position, we will store that as well. And using that information, I can play that reel one by one at a particular speed that we desire to play at, and that will we can show it using a UI in our or a simple animation in our UI. So basically, that is the example that I wanted to tell you. We can make a movie out of it, the sorting algorithm. The state one by one we will store in an array, and we can loop through it at a particular speed. I will tell you how to loop through it at a particular speed. You might be wondering, like, even if I store this uh, information, the state, in a particular array, and if I want to loop through it, the for loop also will be running at a particular speed, right? And fastly it will be running, right? You can use that timeout set interval that you are already aware of, right? I can also I'll be using a different approach basically. So now let's go back to the component breakdown. Basically, before going into the code, before showing you the code, like how different components are, let us break down the components. What are components are required here, right? So bar, the first of all, the bar is required, which will represent the value of the array. So here you have to keep something in mind, like the value of the array can be anything, right? Can be 100. So how will you define the length? How will you define the length of the bar? Because you have to show it in UI. Like even if the array length, suppose if the array is like the value of the array is 1000, you cannot create a length bar of length like 1000 into 100 pixel or something, right? So it should be fitted on the box that you have provided, the div that you have provided, right? So what logic we have implemented here? Basically, suppose there are different elements. So the maximum element, the maximum value which is there will be a standard size, okay? And compared to that, other elements will be set at a different size, right? So I will show you the code how I converted it. So this bar is the first most important thing. Second, it comes with the algorithms that will have to be ready with the algorithms pre-written, right? So that I can make use of those algorithms to define what steps are involved there, right? Then there is an array input, right? If you see here, array input, like I have defined here, basically two types of input. Like if you want to input array length, it will generate a random array of that particular length. And if you want to input an array separated by space, that is also possible, right? Now after this, what is the next thing before looking at the code? Then there is the speed input, right? So this is the speed input that I am showing you here. So basically you can control faster, slower, whatever at whatever particular speed you want to see the visualization, right? Basically it will be helpful for you in the auto mode. And basically this is the input type of slider, right? A slider input that gives you a maximum and minimum value, between a maximum and minimum value basically. Then it comes the sorting. Then it comes the algo select. Okay, so what is algo select? Basically What it has basically, it is a select option and it has different options to select. Like I have implemented three algorithms. In the same manner, you can implement different algorithms and you can provide an option here to select different algorithms, right? So now you have understood like how to break down the components, break down the different components. Like first, the user will select the algorithm, then he will select the speed, then he will input the array, then he will have to basically sort this array, and then he can visualize either step by step or in automation mode, right? So basically, let's now jump into the code. Let's look at the code, how you can design things one by one. So first of all, the most important thing, that is the first component that I have used. Basically, I have used React. If you don't know React, first of all, you will have to go through it. Okay, but the same logic, if you want to implement in normal vanilla JS also, that is also totally fine. There's no issue, but you should be having an understanding of React, so that you can at least understand the code, how it works and how it is written there, right? The algorithm, the approach is pretty simple. Believe me, the approach is pretty simple. I will create a movie out of a sorting algorithm. That is it, right? So now, what is there? Now, first important thing, that is a bar. Okay, first important thing, that is a bar. So what is this bar taking as an input? The bar taking as an input first is your height. What height might be there, right? So you will have to define the height. What will be the height? And again, I told you maximum height. The maximum element in the array, you will have to pass it there as well, because you cannot define or you cannot show infinite length of bar there, right? So there should be a standard maximum size that should be having. So one logic that I'm using here, what will be the height of this particular bar? That is your height, particular height, divided by the max height, and whatever pixel, if you want to use percentage, or if you want to use viewport height, that you can use here basically. So this is the ratio. Basically, I'm using ratio here. This is in the ratio that my bar should be there, right? So now this is the BG, that is the background color, right? So sorted, if it is sorted, like and the swap element and the minimum value. So what are these things basically? This background is whenever the element is getting compared, I will pass a value, boolean value, true or false, right? A boolean value, true or false, if this particular bar is getting compared or not. If it is getting compared, it will be red in color, right? Then come to sorted. If this particular bar is in a sorted position, the color will be green. If it is a swapping element, basically, if this particular element is getting swapped with each other, like two bars are getting swapped, right? Then at that part of time, I will be representing it as a sky blue color, right? Then minimum value, that will be in selection sort, that will be useful, that I'm displaying as a yellow color, right? So that is pretty simple. And below that, I'm defining, basically I'm displaying the particular value, that is the height of that particular bar, that is the element of the array, right? So this was your bar, right? Now how to use this bar and where to use this bar? Now second important part comes in, that is your algorithm. And those are the really important parts. Okay, so I have created a separate folder for algorithm. Basically, there are bubble sort, there are insertion sort, there are selection sort. Now if you notice this thing, if you notice here, this is a pretty simple bubble sort, right? This is a pretty simple bubble sort logic written there, that accepts an array, that is accepting an array. And what is running? It is running a nested loop, and it is comparing as per the logic. If that doesn't fit at that particular position, it swaps the element, right? Now if you notice at line number 3, I am using a real array, right? I'm using a real array. I told you in the beginning itself, right? you need to store the information of every state, basically every state what array goes to. Initially the array will be normal, then the array two elements get swapped, then the state of the array will be something else, then again the two state get swapped, then the state of the array will be something else. So if you notice, I have taken, if you notice here, like I am pushing in the rail, I am pushing like four values here. If you notice here, I am pushing four values here. Like you, the question might be coming to your mind, why this four values required even, right? So I can, you told me that you can push the state of the array directly, right? So what is here, basically this, if I destructure this property, if I destructure it, the first element is the element that is getting compared, right? First and second element in this array is what that is getting compared. So compare one, right? And this is compare two. And this is why this is null and null. I will show you gradually. So this is null. Initially, this is also null. Now what happens? Once the for loop was running, the state of the array. Now here, what I stored in this reel, that this element, jth element and jth plus one element is getting compared, right? So I will send this to this reel that these two elements are getting compared right now, right? So now remaining two elements remain null. So why it is null? Now if you notice here, if there is a swapping happening, right, that means two elements are getting exchanged with each other, right? Now at that point of time, I am also pushing the same j and j plus 1, right? Why is that so? So can I ask you a question, like if two elements are getting compared, and those two elements doesn't fit at a particular place, those two elements will be swapped, right? Suppose this compare one, whatever element has, two elements have been compared, if those two elements doesn't fit at that place, like for example, if I show you that sorting example, like this 1 and 5 is getting compared here, like for example, let us reset this and let us put this bubble sort here, and let's put an array length, let's sort it, and let's visualize this step by step. So basically what is happening here, so basically if you notice that these are the two elements that are getting compared right now, right? And basically these two elements doesn't fit at proper place, because the next element j and j plus 1 element is greater than the jth element is greater than the j plus 1 element, right? So now the same two elements will be swapped, right? So same thing is happening here as well. So now what happens, basically whatever element, whatever array, whatever element, whatever index that you are comparing, if that satisfies the condition, those two elements only will be swapped, right? So now whenever it is swapped, I am passing the I'm passing the current status of the array. Like basically if the array is at a particular position, like this reel, we are pushing it in the particular reel, right? So now here, if you notice, let me write it here. If you notice, like this is your swapping, right? This element was got basically swapped with this particular element, and this is array here, and still fourth element in this array is null, right? So now if I show you in the next step, what happens, basically now here all the other elements are null, right? And the fourth element has some value. Why is that some value? If you look at this logic here, if you look at this n minus I minus 1, what is happening here basically? So at the end of this internal for loop, at the end of this internal for loop, if you at the end of this internal for loop, like what happens, the last element got sorted, right? So now if you are able to understand this fourth information, this fourth information is the index of those that element that is sorted, right? So this is n minus I minus 1, right? And after this whole information, like after this whole logic is complete, both the for loops are done with their execution, then at the end the last index is also, if I show you, the last index is also basically is at the sorted position, right? Same thing is happening here. Like if you visualize this one by one, it will come there one by one. These are coming at the sorting position, and at the end of the day, like at the end of the loop, basically both the for loops, once they are done with execution, what happens? The last element gets sorted. So why we need this information? Why we still need this information? So now if I show you this thing, if I show you why we did this thing, like basically we created an array, like first in suppose this reel, first reel 1. So by default this reel 1 in your state it might be stored, right? The original array is already stored there, so you don't have to store it again, otherwise it will create a basically repetition kind of thing. So basically in this reel 1 that is getting pushed here, first what is getting there, which all elements is getting compared, right? Compare one element with the second element, other element, whatever element is there, right? Then this array we are not passing here, both the elements are null, right? Both the elements are null. Now in reel 2 what happens? Now here if you notice we are passing the same compare element, the same element that we were passing j and j plus 1. Why? The element that are getting compared, the same element will be swapped, right? So basically we are sending one index of the element that is getting swapped, the second element, right? Then here also it is first element getting swapped with another element, whatever element is getting swapped, that information we are sending. Also we are sending a clone of the current status of the array. If you don't know, basically this is basic JavaScript, normal JavaScript. You need to spread this array, you need to send a new array. If basically arrays are non-primitive data type and these are referred by reference. Okay, if you pass this original array directly, it will pass the reference, not the value. We want the value there, like we want a totally new array. It should not be affected. This reel should not be changed, right, at the end. So that's why we are spreading it. Now the fourth element, let's see, null. Now if you notice reel 3, what is happening here? In reel 3, once this first, the inner for loop has completed its execution, that means the last element will be at sorted position, right? So now what we need here, so every other element will be null in this reel, null, and only the last element that got sorted, that means currently the last element is here n minus I minus 1, so that I will pass here n minus I minus 1, right? So the same information if you want to store in an object, that is also possible. Like reel 1, you can store it, let's say reel 1 is here, let's say an object, right? And let's say in this object what you want to store, let's say what all values were compared, right? So let's say compare value, right? You can initially keep empty array, right? But if both two things are getting compared, you can write compare one, compare value 1 with compare value 2, right? Then you can store like what all values, what was the new state of the array. So currently, let's say if nothing is getting swapped, let's keep it null. And if, which is the sorted position now at this point of time, currently it is null, right? Similarly, real2 also you can store. Let's say copy it. Let's copy it here, paste it here. Let's say real2. In this real2, what is the compared? Basically, what happens whenever it is getting swapped? Whenever it is getting swapped, what is happening here? This getting swapped with. So if you want to use the same value, that is also totally fine. But suppose if you, unlike me, if you don't want to use the same value, you can create another array here. That is also good, right? You can create another array which element got swapped, right? Swap 1 with swap 2. So currently I'm not using it. I'm saving my memory as much as possible, right? So basically, why I'm not using a different value for storing the swapping elements, right? The thing is that, what is the reason behind this? Like whenever things are getting swapped here, if I show you, right, swap 1 with element swap 2, right? And in this position, I will send the array here, and sorted position will be null. Similarly, the third case, that will be, you can store as you want. So here in this case, it is null, right? And this is also basically null. And this sorted position becomes n minus I minus, right? So no matter how you choose to store the real, that's your choice. Either you can store it as an array, either you can store it as an object, that is totally fine. But you have to store basically every state of the array that is getting changed there, right? So at every loop, this is the critical position where things are getting compared, right? And this is the second critical position where things are getting changed, right? And this is one more critical position after the internal loop is finished, and there is one more critical position after everything is getting finished. So whatever position you want to record, whatever position value, whatever position state that you want to have a record, there we are pushing the values there. Now if you now I will answer you why I'm passing this array at this point of time only. Why I'm not passing the current status of this array at here and at other positions. No, there's simple logic here. I'm just saving my memory here. Okay, so why I'm saving my memory basically? So do you think that if two arrays are getting compared only, will the state of my array change? No, that's not going to change, right? But if two elements of the array are getting swapped with each other, then only the state of the array will change, right? And in the scenario where things are getting sorted, like one element got sorted, I'm not concerned about what is the current status of my array, because the status of my array, the current status of my array will only change when it is getting swapped with elements, when two elements are getting swapped with each other. Otherwise the array remains same. No matter you compare two elements, but if the elements are at correct position and they are not getting swapped with each other, the state of the array remains same. So in that scenario, why do I need to store the array? Because array, basically if you take a big array size and if you want to visualize this thing, this array will consume your memory, right? Consume some space. So why should I pass it again and again? So that's not a good thing. And also this thing you can use as a condition. How can I use a condition here? Basically, if in any of the array, if I ask you how will you recognize at which rail things are getting compared, and at which reel things are getting swapped. If my third element is null, that means I'm not passing any array there. If my third element of the array is null, that means I'm not passing any element there, right? So what happens there? That means if I'm not passing any element, that means we are comparing two elements. That means array is not changing there. We are just comparing it. But if the third element has been passed, that means the array at this point of time has changed. And if the array has changed, that means the swap has occurred with two elements, right? And the fourth element is still null. That means it has not reached the position where it can fix an element on its sorted position. Where it will reach at that position after the inner for loop has completed its execution, it will reach at a position that it can fix one element that at the sorted position. So that's what we are doing here. So this is the flow of the reel, right? This is a simple bubble sort algorithm. And we are just recording the stages of the array where it got compared, where it got swapped, and where one element got sorted, right? Got placed at the sorted position. And at the end, the zeroth element was it will exit and the zeroth element will be left. So you will have to fix it like the zeroth element also after everything is complete. The zeroth element is also at the sorted position, right? So now this bubble shot, now we have recorded this reel. Right? If you understood this part, believe me, 80% of the part is done. Believe me, 80% of the part is done, right? Now what you have to, now you have an array of reels, right? Similar to this movie, right? What you have to just to do, basically what you have to do, just play the reel, simple, at whatever speed you want. Now you have this reel stored here. Now instead of returning this sorted array, we are returning this reel, right? Because we are concerned about visualization. I want to visualize things. Okay, how this was sorted. And for that, we have recorded every particular step in an array. You can use array as well. You can use object as well. So now this algorithm is ready, right? So now what happens here? So let's go to components. Now bar is there. Now what I'm doing here, in this input sidebar, I have created a sidebar here. Right? There are different elements there. First element, that is your reset button, that is resetting basically the application, right? And this is the algo select component which will select the algorithm, and this is the input speed input that will be selecting the input, and this is the array input which is getting the input values from the user. Okay, so let us explore one by one. So basically, let's go to app.js first. Okay, app.js first. I have defined few states here. Basically. First state is your algorithm. What is your current algorithm? Basically, by default, it is bubble sort. Whenever you reload the application, it will be bubble sort only. Then, what will the default length? Basically, whenever it gets a reload, what is the length of the array, right? What is the default speed? It will be 1000 millisecond I have kept, right? Then input value, right? Input type basically, right? Input type. If you notice here in the application, we have taken two types of input. Like either if I reload this application, either you can take array as an input. Like if I store 30, it will give you that particular length of array. But if I want array separated by space, basically this will give you array elements as per your wish, whatever element you want to enter, and it will fit as per it is, right? If you put an an extra space, it will consider as a 0. So now let's come back to the code. That is your input type. Then array, whatever the array is there, that you will have to set, right? Then input value, whatever input value, by default it is 10, right? And mode, basically that is the mode, that means which mode you want to sort it. That is step by step, like basically after sorting it will work only. Once the sorting is finished, then only you can switch toggle between two modes, automatic or step by step. Both options are there, right? So why this option is available to you, why it has been possible to you? The reason is you have recorded each and every step, each and every like kind of reel. If I annotate it here, like if you have stored reel 1 here, you have stored reel 2 here, if you have stored reel 3 here. Now you can just play it as per your wish, right? As per your wish. You can move like a movie, play it as a movie. Now if you want to move step by step, frame by frame, if you want to watch, that is also possible. Because every possible changes that has been made in the array, whatever was compared, whatever was sorted, whatever was swapped, you have recorded it and stored it at a particular place, right? As form of a reel, as a movie, right? So that's why you are able to visualize in both the fashion. So let's come back to the code here. Now this was basically the states that we have defined here. Now a few functions that I have defined. Algorithm change, that will change the algorithm, like whatever, if the user select different algorithm, it will change the algorithm value. Speed change, it will change the speed. Handle input type, it will change the input type of this whatever input type. If you want to use length, or if you want to use array separated by script, that is your choice. Set mode, initially it will be in auto mode, but if you want to step by step, that will be changed by step by step. Then handle length change, that is the logic written there. So basically we are getting the value from the input value, and we are setting this value to the input. Basically whatever input, whatever the value the user input, we are setting it here. Now what condition I have written here? If the input type, that means is length, input type length, that means the user is inputting the length of the array that he wants, generated automatically. So if the user has the mode is the user has selected an option of inputting length, the length value will be set, right? Then if the input type is array, then what is the value? What will the value? First of all, you will trim the value, right? Whatever the user has inputted there, you will trim the value, split it with the space, because we have entered the value separated by space, and just convert it to number, because if something comes from the DOM, it will be by default as a string, right? And set the array directly here, right? We are not setting directly array in the length case, because we will be generating array at different component. But in case of if the user is inputting array separated by space, then in that scenario you will have to split it and map as a number and set the value. Then handle reset, I'm currently reloading it. I'm not I don't want to make confuse you. Basically what you can do here, instead of reloading, what you can reset all these states one by one, and there are few more states that needs to be reset, right? And on the home page, like basically this navbar is visible and this sidebar is visible, which is taking all these functions as a parent, and this visualize is present, the visualize page is present, that is taking this in as a parent, right? So now let's define this component, that the flow one by one. First is your navbar, that is taking input as a handle mode. Okay, so let's go to the navbar.jsx. So now what is happening here? There are two buttons, right? Let's forget about this navigate for now, that was not important. So now this is the handle mode auto and handle mode step. From where this handle mode is coming? That is coming from as a prop, coming from the app.js as a prop, that is handle mode, that will change the mode to either auto or a step, right? So that is your navbar. Now it comes to the now let's comes to the basically this sidebar, right? Let's come to the sidebar. So basically what happens here, we have passed different methods here. We have passed different methods here. We have passed different functions. Basically, first is the select algorithm, because every component, like for the algorithm select component is available in the sidebar. Then on algorithm change, like what will happen, the speed, the value of the speed we are passing. On a speed change, what will happen, length change, input type, handle reset, and input value. Everything is present on the sidebar. That's why we are passing it as a param here on the sidebar. Now in the sidebar, if you go there, let's go to the sidebar. We are accepting these functions here, and to modulate things, basically what we have done, we have kept a button here, a reset button. That was a single component, so we didn't create a separate component for that. Then comes the algorithm select. Here it takes the selected algorithm. That will be a selected algorithm, whatever algorithm that we have selected, and on algorithm change, that function that we have passed from app.js, that will go there. Now let's go to the algo select. In algo select, we have a simple select tag. In algo select, we have a simple select tag where the value are respective algorithms, that is bubble, selection, insertion, and whatever the value that we want to display, right? And on change, like on change, we have assigned this on algorithm change method, and on the value, whatever value will be there, that is also coming from the app.js. So that is your selected algorithm, right? Now let's come back to the sidebar. Now what is the next element? Now next component, basically there is a speed change. Now one thing you have to keep in mind, all the methods that are getting passed here, are coming from a single component, that is your app.js. All the states are defined here. We have passed into sidebar, and basically sidebar we have passed into this algo select, right? Then in the sidebar, if we have speed input. So let's go to the speed input. Now speed input, we have written there faster, slower, like in which direction it goes faster, it will become faster, in which direction it will become slower, that we have defined there. Type will be it is the input type that has a range. ID is that it should be for CSS. Minimum value is 1 and maximum value is 2000. That means in millisecond I have kept it here. And value we are passing so that the slider remains at the position that we have selected. And on change, the speed change, whatever the function that we have defined in app.js, like if you go there on the screen handle speed change, we are setting the speed to that particular value, right? So that is your speed input. Now let's come back to the sidebar again. Then it comes to the array input. Okay, then here it is input type, then handle input type, because you have to change the input type as well, what the user want to input. Then input the input value, if the user is inputting whatever is the user typing there, he should be seeing that input, so that input value is also there. And the length string, again these all methods are coming as a prop, and these props are passed where in the app.js here, and all the functions has been defined there. Now let's come to the array. Okay, now what is here, basically input type is defined here, right? So label is there, select input type. Okay, there's a select option, whatever the user selects, either length or array separated by space. Now the corresponding value will change using this handle input type function, right? Label, we have used conditional operator here. Basically, if the input type is length, enter the array length, and if the input type is other than length, then enter array separated by space. Now input type text, simple input box is there. Same input box, you can use it for both the purposes, right? So now the sidebar is complete. Sidebar is okay. We have selected the algorithm. We are able to reset the application. We are able to select the input. We are getting the speed input basically from the user. We have also got the array input. Now everything is available here in this state. Once the user has selected from the sidebar, everything comes in this state, right? Whatever is the length, whatever is the array, whatever is the mode, whatever is the input value, whatever is the algorithm, right? Now it is ready, right? Now let's come back. Now what is the next component in app.js after neighbor and sidebar? That is your visualize, right? So I have used pages basically. I have separated this component to make it distinguished basically from other single components. So this visualize component is returning whatever sorting algorithm that we have testing basically. That is the component there, and the same algorithm, that same mode that we are passing here, same thing, the prop that we are passing here, the same thing we have passed here in this particular component. Now here why have we used this visualize component? Now currently what I'm doing here, I'm using this single component in both the modes, right? I'm using the single component in both the modes, like in auto visualize as well and a step by step as well, right? But in case if you don't want to use the single component, and if you want to define a different different properties, different parameters there, different way of visualizing things in what you can do here, simply you can create routing here kind of thing, and you can create multiple components after this. So that's why I kept it. You can edit it, you can change it as per your wish, right? So now let's go to the sorting tab first. Basically I will be using this single component. So these are accepting input type, whatever the user has selected, whatever input type. If it is a length, okay, and if it is a array input, like whatever the array the user has selected, the length, the algorithm, the speed, and the mode, right? Everything is coming from where? Everything is coming from this place, right? Now let's go to sorting type. Now this component is really important you to understand. This component is really important you to understand. So here also I have basically I'm accepting length, algorithm, input type, and input mode and the speed, right? Here also I have created an array. Why I have created array? But the reason is you can create it here as well, or you can use that particular array as well. But if the user has, basically what I'm doing here, if the user has selected input type length, so what I'm doing here, I'm creating a random array of particular length, random array of that particular length, whose maximum size I'm keeping as 40, right? And I'm setting that array, right? And initially, if you are creating an array, random array, in your reel, whichever reel I am using to render the component, initially it is null, right? Everything is null. So what I'm doing here, I'm setting this reel as a new array so that it should be present in my DOM, it should be visible in my DOM. Because the reason is, in this reel there's nothing, right? So then if the user has selected length, we are creating random array. If the user has not selected length, we are using the array that has been inputted by the user, separated by space, that we have shown in the app.js file, and we are setting the reel as it is, okay? And we have defined different states here as well. I will tell you what are the states here. This is the array, you got it, right? This is the array that will be used for sorting, right? Then compare and set compare. There will be an array of elements, basically two elements. Either you can keep it as an array, or you can keep it as an object, as a B element. That is totally fine. There will be two elements. Why I'm kept it array? Because it becomes easy to compare, right? But it becomes dot include function if you use it. Dot include function if you use it, it becomes easy to compare whether the element, the index that we are comparing is present, is set as compare or not. Okay. So sorted values, basically whatever whatever elements that are sorted already at the sorted position will be stored here. Swap element, whichever element is getting swapped, that will be stored in this array, right? the reel that we initially it is set to null. Only one reel is there. Okay, that is everything is null. Then reel number. What is this reel number? What is this reel number? Basically, this reel number will be used once you visualize this step by step. If you click on this step, what will happen? This real number will change to from 0 to 1, then from 1 to 2, then 2 to 3, 3 to 4, kind of thing. This is the real number, right? Sorted. This is a Boolean state basically. Why I'm using this sorted? Because I don't want to execute any function. I don't want to execute any visualization in the middle of the sorting process. The reason is the sorting process. Suppose if your visualization starts in between the sorting process, you will not be able to visualize things in clearly, right? So once the sorting is complete, 100% done, okay, my reel is available, the full reel is available with me, then only I will start visualizing. So that's what I'm using here. If the array is sorted or not, initially it is first, that means it is not sorted, right? Minimum value, again I told you it will be useful in the selection sort because we are finding minimum value and we are swapping with the element, right? Initially it is null. Okay, so now what is happening here? What is happening here I will tell you. So here what I'm doing here, basically in this, if you look at this component structure, here is your bar. What I'm returning here is your bar, right? We are mapping through the array. Whatever array is available, we are mapping through the array, right? And we are passing the height of the array as the element of whatever element is present in the array, right? So basically we are sending height value as the element value one by one, like in this bar component that we are that I have showed you in the beginning itself. We are sending height here. Now what we are sending here, maximum height. So how will you get the maximum height? Simply using mat.max property from this array, right? I got this maximum value. Key, you can use index, that is totally fine. Background, that's why I told you in the beginning. If you notice, now you will understand why I used array, not an object or something, right? Now if you want to send a Boolean value, whether the particular bar that is getting rendered is getting compared, or it is sorted position, or it is getting swapped, or it is minimum value, then how will you get that information? Simply you will store it in an array. If their compare value, whatever comparing value is there, you will store it in an array. And what you can do, you can make use of this dot includes function that will return you a Boolean value. If its index is there present in that array, that means it is true. That means this particular element is getting compared and the value, this background bg, will be passed. Sorted, if it is at sorted position, that means if the sorted values, that is including the particular index, that means it is at sorted position. Similar to swap and similar to the minimum value, because minimum value will be only one, right? So that's why we have not used array. We have used that null value initially. So if the minimum value matches, then that particular bar will be the minimum value, right? So that is the case here. Now this is color description here. Now this is your color description here basically. Now what happens in the color description? Simple. Whatever color for grading I have used to show you, that red for comparison, and blue for swapping, green for sorted, and yellow for min. That is it, right? Now if you come back here, now we have three buttons here. Once you click the first button, that is your sorted, like sort button. On click of this sort button, whenever I click on this sort button, what happens? This particular function will be executed, and till that point, these two buttons will be disabled. Why? Because it is not sorted. The array is not sorted yet, so reel is not available to play. So that means what I did, so that the user don't get confused, I have disabled the button simply, right? Because the reel is not available with us, so what will we play? Okay. So now once you click on this sort button, this will execute this handle sort array. So where is handle sort array? Let's go back to the handle sort array. Here is the handle sort array, right? So array is getting sorted with this method. So what are we passing here? We are passing two information here. That is the algorithm and whatever array you want to sort it. Okay, whatever array. I don't want to make changes in this existing array, so I have spread this array in a new array, and we are sending that array. From where this method is coming? This method has been imported from utils. Okay, sort array. Now based on this algorithm that we have passed here, if the algorithm is bubble, it will use the bubble sort algorithm that we have written here. If the algorithm is selection sort, it will use selection sort, otherwise it will use insertion sort, because we have implemented 3 algorithms till now here. Others, rest you can implement in a similar fashion. And it will return the sorted array. It will return the sorted array. If you notice here, I told you the sorted array. But if you go to this function, the bubble sort, the selection sort, and insertion sort, right? What are we returning in real? Are we returning a sorted array? To be honest, no. We are not returning a sorted array. We are returning all the steps. We are returning this reel that is involved in all the steps to reach the sorted position, right? One by one, right? We are pushing every step involved in a reel, and we are returning the reel. And the same reel that this, if you go there, this function sort array is returning. Once it has returned this reel, now this reel is present in this array. Now, if this reel is present, that you have to cross check, otherwise your application will break. Suppose this is coming undefined or something. So if this reel is present, we are setting this reel that we have defined the state here. We are setting this reel here. Now, and once the sorting is completed, we are setting this sorting to true. Sorted to true. That means now the sorting is done. Now you can play the reel. Now we have two information. That means sorting is complete, right? The sorting is ready, and the reel that we want to play is available with us in this reel, because we have set the reel, right? So this button function is done. This button's execution is done. Now, if you click on this steps button, if you click on this steps button, what will happen? It will execute handle next. What it does in handle next? For now, just ignore this line number 85. It sets the reel number to previous plus 1, right? That means if your reel number is currently 0, it will move to 0 plus 1, then that is 1, then plus 2, then 3. That we are able to see here, right? 1, 2, 3, 4, like this, right? 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, right? That we are able to move forward. And whenever this reel number changes, we are calling this, where is this render reel? Okay, whenever this reel number changes, you will have to change this UI as well, right? Because changing the index will not render anything on the UI. Changing the index only will not render anything in the UI. So you will have to keep a track of the changes if the reel number has changed or not. If the reel number has changed, what you will do? If the reel number has changed, a render reel function that is getting executed. So what this render reel does, and this condition, if you notice now, what is happening here? If it reaches the end of the reel, it should return. It should not do anything. Otherwise, your application will break, because you will not. If the array reaches its end, basically it will not be iterable anymore, so it will break. Okay. So this condition is important to put it there, right? Now, whenever this reel is changing, whenever this real number is changing, whenever this real number is changing, we are rendering this, we are executing this render reel, and we are passing the current real number there. We are passing the current real number there. What is this render reel doing? Let us come back here. What does this render reel do? Now, this render reel, in this render reel, we are passing the real number as an I, and it is using this function, that is a step reel, that is we are moving step by step. So what is this step reel? That is coming from utils again. Okay, this is accepting the current real number. Okay, the real array that they have passed here, the real array that we have stored here, the real array that is stored here after sorting, right? Then set compare, then set swap element, then set minimum value, then set sorted value, and set array, right? Why we are passing this thing? Whenever I change the real number, it should, if whatever value the reel is having, it should render the UI as per that value. So we will have to set this value so that my bar changes its height and changes its color as well. So the same method that we have written here, like set sorted, set minimum value, and all those things that we are set compare, set sorted, swap element, set minimum value. This methods that we have set us, we are basically passing it there. They are using it like this. Okay. So now here comes the logic. Now I told you we are basically sending 4 elements, right? But in case of selection sort, what will be there? One extra information will be there, that is your minimum element. In case of selection sort, one extra information will be there, that is the minimum element. So that's why this is the 5th element, right? If you go to the selection sort algorithm, so there is a 5th element that is getting passed here, right? So in bubble sort, like only 4 elements are there. In selection sort also there are in selection sort there is a 5th element. In insertion sort there are 4 elements only. Okay, so same thing. Let's come back here to the step reel. Now, how the reel will be rendered? That's pretty easy. You have the information. What are these two values, x and y? Either it is getting compared, x and y, or these are getting swapped, right? How will I determine whether it is getting compared or whether it is getting swapped? If this array exists, that means these two values are the values of the index of the elements who are getting swapped. If the array is not present, that means these two elements are the elements who are getting compared. And what is the 4th index? This is the index of the element who is now reached at the sorted position, right? And the minimum value that will be coming once we see the selection sort algorithm, and we are getting this real I. We are destructuring it. Basically, we have destructured it, and now we have set the compare to x and y, because initially either it is getting swapped or not swapped. Compare will happen. Either it is getting swapped or not swapped. Comparison will happen there, right? So compare element we have set as x and y, right? Then swapping, currently it is not happening, so set it to empty. Every time we will have to set it empty. The reason is, if the elements are already present, and if you don't switch, basically the two elements have been swapped, right? So now when it moves forward, then another 2 elements will be swapped. No? So every time you will have to set it to an empty array, otherwise the same elements will be visible. You will not be able to visualize in better fashion. So swap elements we have sorted, right? If the minimum element is available, that will be available in selection sort. Set the minimum value of that particular index. Else, if I is equal to reel length -1, that is means it has reached the end of the reel. If the minimum value you have found, whatever minimum value you have found, just set this to minimum value, that particular set that array to the set minimum value, But if the iteration is completed, like it's done, and you didn't find anything, set it to null. Once one iteration is done, set it to null. Otherwise, it will keep on showing the same element as a minimum value, right? Now, if index is not null, that means what is the fourth value? What is the fourth value? If you go to the bubble sort that I have explained here, what is the fourth value here? The value of the element that has reached to its sorted position, right? What is the fourth value that has reached to its sorted position? Now, what happens here? The index, if this index is not null, that means there is an element that has reached its sorted position. Then in this sorted value, I will not set this particular index, but there will be other elements also. There can be other elements also that has reached to its sorted position. So I will first spread the other element which has already been set. Then I will set the new index. Simple. Now the same logic I told you. If the array is present, what will happen? If the array is present, that means swapping has happened. If the array is present, that means swapping has happened and the state of the array has changed, right? If the state of the array has changed, that means this UI needs to be changed, right? And for that purpose, that means the bar state needs to be changed. How will the bar state will be changing? The bar state will be changing based on this array. So from where this array will become? This set array. So now, if array is present, that means some swapping has happened, right? So I will set the new array, and if an x and y are not null, that means you will have to cross check. If they are not null, this x and y, that means if the array is present, that means swapping has done. You will set the swap element to x and y. Simple. And based on that value, the bar will change color. Based on that particular value, like for example, BG, that compare, if the compare includes that in particular index, it will be red. If it is sorted, it will be it is true. If it is true, it will be green. If it is swap element, if it is including the index, it will be blue in color, and minimum value, it will be yellow in color. So true and false value we are sending there, and based on the true or false value, we are rendering the background color, right? Simple. So now you have understood what clicking of this button does. That is this particular button, the step does. Okay, it moves one by one. Now how to visualize it automatically? So this is you might be seeing this disabled button, right? Disabled basically value. So basically, whenever I selected this step by step or auto visualize, so basically what is it changes to particular. Currently, it will not be in the state. Yeah, now it is changing. So basically, whenever you change, it visualizes step by step or auto visualize, whatever you want to do, that is switched. So this mode is switched. Based on that mode, we are just disabling the other button, so that if you execute both the button at the same time, then there will be a kind of mess, and your UI will not be in a good state to visualize the algorithm, right? So now this state is clear. This handle next changes the reel, and based on this reel, based on the change of this reel, we are basically executing this render reel. And what this render reel does, it calls this a step reel function and changes this a step reel, basically a step by step, basically whatever reel we pass there, whatever reel index we pass there, based on that index, it changes the value of different parameters, and based on the different parameter, your bar changes, right? Now let us come back to another feature in our application, that is the auto visualizer, right? Based on the auto visualizer, right? Once you click this button, the third button, what happens here? This will execute handle play. Now let's come back to the handle play. What this handle play does? So basically we are consoling this, right? We are not. So let us Let me show you something. Let me show you something. What will be the state of this reel basically? Let me see if that, let's say bubble sort, and let's say this is 10. Sort it and let's click on visualize. If you look at this thing, look at the size of this array. This is 73. What is happening here? We have all the reels here. We have all the reels here. What is the reel? That means at this point of time, 0th position, this 0 and 1 value is getting compared. Then 1 and 2 value is getting compared. Then 1 and 2 value are getting swapped. Why? Because this array is present there, right? That means swapping is happening, right? Then 2 and 3 value is getting compared, 3 and 4, then 3 and 4 getting swapped, 4 and 5, 4 and 5, then 5 and 6. Similarly, right? At this point of time, when it reaches the end, 9th index, that means there are 10 elements there. Then everything is null, and we are setting this 9th index to a sorted position. So this is your reel. You might be able to relate this thing to this thing, right? So basically, this is a kind of moving picture, right? Similarly, that we have created moving, like basically moving states of your array, right? So let me close this thing. Let us come back to our this thing. Basically, whenever you click on this button, visualize, this will create a handle. This will execute handle play, and based on this handle play, this will execute the play reel. Okay. So play reel, what it does basically, initially what we are passing, we are intentionally passing 0th index, basically, because I want to start it from exactly from 0, right? Even if you don't pass, the visualization will be fine, but it will miss the first index element, right? So because the reason is initially it was null, and if no swapping or no comparison happened there, so that will still be null at that point of time. So what happens here in the handle play, this reel is there, same component we are passing here, same component, set compare, set swap element, set minimum value, set sorted value, set array we are sending there. One extra thing we are sending there, that is reel also we are sending, the complete reel. Along with that reel, we are adding 2 0th index of the reel inside the array to make it more smooth, the transition to make it more smooth. Okay. One extra thing we are sending, speed. From where this speed is coming? From the prop, right? From where we are passing it here? If you go to the page, visualize, from here we are passing this speed. And in visualize, from where it is coming? It is coming from app.js, this is speed, right? This particular speed is coming there. You can use a state management if you don't want to, basically I don't want to make it more complex here. You can use any state management, context API or something, so that you don't have to do a prop drilling kind of thing. Okay. The application is pretty simple, only 1-2 levels, so that is totally fine. You can use it. But if you if you want to explore it further, if you want to make it more not that complex, so you can use Redux, or you can use context API. That's totally fine. Okay. So now what we have done, yeah, let's go back to this position. Now in this handle play, what we are doing, this play reel. Okay. Now speed is passing. Now here comes the most interesting part. In this handle play, basically play reel is getting there, all the methods are getting there. Now here what I'm doing, I'm executing a while loop, right? But you might be wondering, I'm doing this exactly same thing that I was doing here. I'm doing exactly same thing that I was doing here, right? Exactly same thing that I'm doing here. So here what I have done, basically, you can use set interval as well. That's totally fine. You can use set interval as well. But what I have used here, if you notice, I have used something called pause. There is a method which is a pause method. If you notice, I have used await here. That means, what is this? This might be returning a promise, right? So exactly the same thing I have done here. Same logic, exactly same logic is written there that we have written in step rel. Only thing is that at every iteration, after every iteration, I am pausing this loop for a particular amount of time. And how am I doing this? How am I doing this? Basically, I am basically blocking this for particular amount of time, and that is speed, that is a millisecond, basically 300 milliseconds, 400 milliseconds, 500 milliseconds. I am blocking this code, so it looks like one step it went. So basically what I'm trying to say here, like basically whenever there is a sort, if you click on this visualize, so basically after every iteration, what has happened, it waits for a particular amount of time. That's what I'm doing here. And how I'm doing here, believe me, pretty simple. Just return a promise that will resolve after that particular amount of time. Simple. I'm returning a promise that will resolve after that particular interval of time. So I'm pausing this for that particular interval of time. I'm using a while loop. Simple. And I'm exactly doing the same thing, looping one after another, and it is visible in automated mode. Basically it is looping one reel to another reel, one by one, but after a particular delay amount of time. Okay, so the same thing can be done using set interval as well. No issues, you can explore that way as well. So that was how you can create. There's nothing left here. Basically that was how you can create. So basically these are whenever the length changes, whenever the array input changes, everything should be reset. Okay, whenever the user length changes, whenever the user changes array input, everything should be reset. That we are doing here. Okay, now these were the two features. Again, I'm only implementing the handle next. You can implement the handle previous as well, basically, right? You can provide a previous button, and you know how to do it in the reverse fashion. Just play the reel in the reverse order, right? So same thing that we have done here, that we will doing in the reverse fashion. Now let's this was for bubble sorter. Similar application. Now once you have created this application, now if you want to add an extra algorithm, you don't have to touch any component. You don't have to touch all these components. Just add, suppose I want to add down the line, I want to add selection sort. What I will do here, I will write the algorithm of selection sort. And I will create a reel, and I will push that reel. I will first figure it out that what are the critical points, what are the critical positions where something is happening. Happening means two elements are getting compared, or two elements are getting swapped, the state of the array is changing, or the element has reached towards particular position. In case of selection sort, there is an extra thing that is happening that I have kept as a last. Why? What is the minimum element? Because we are in this case we are also finding the minimum element, right? Because if you notice here, like if I reset it here, let me reset it. Let me create a array of size 50, and let's select selection sort here, and let's play it basically in the fast mode. Let's sort it here, and if you visualize things, if you notice here, there's a yellow bar there, right? There's a yellow bar there that is getting, if you see that yellow bar, that is your now if I reset it again, I will show you again. Basically fast, not that fast basically. So let's use sort it, and then click on this visualize. If you see this yellow, these are the minimum elements. Whenever it is encountering any minimum element, it is setting that value to minimum element, right? And so same way that you have to visualize what are the critical positions, of that array, the sorting algorithm where I need to push. It is not compulsory that every time you need to push 3 or 4 times. It might be more than that. In quick sort, it might be more than that. So I figured it out that this is a critical position, this is also a critical position, this is also a critical position, this is also a critical position, and everything is done. When everything is done, this is also a critical position, right? Then when it comes to insertion sort, similar, exactly similar thing that you have to do. Write the logic of insertion sort. Write the logic of insertion sort. Basically, once you have designed this component for bubble sort, you don't have to worry. You don't have to even touch any of this component. Okay. If you don't want to modify do a major change, you don't have to touch any of the component. You just need to provide the reel of the movie. And what is the movie? That is your sorting algorithm. Just provide the reel of that movie and you will be able to play it. Simple. Your theater is ready, like the pages, components, every component, like your sheet, everything, screen is, everything is ready, right? Only thing, out of the sorting algorithm, you need to provide the reel. Once the reel is present there, you will be able to play it, right? Now what we can do here, similarly, that we have written an insertion sort algorithm, and what we are doing here, we are pushing the reel in a critical position, wherever you feel that this is the critical position where some change is happening. That means two elements are getting compared, two elements are getting swapped, two elements are getting the element has reached to its the sorted position. The element has the array status of the array has changed. So you can, every instance of that, every state of that array, we are pushing it here. Again, I'm telling you, you can use either array or object, whatever the way you like. Now, somewhere down the line, if you want to add quick sort here, let's say I want to add quick sort here, just add a file here, quicksort.js. I will not be extending this video further. Basically, it will be really long. Then, but if you want to add a basically quick sort here, now what we have to do here, simple thing. What you have to do here is write a function quick sort, and what this quick sort will do, it will take an array as an input. Similarly, whatever you want to do here, you can perform your sorting, but only thing that you need to return basically const, that is your reel. Initially it will be empty. Find the critical points, and push it to the reel, and at the end of this function, return this particular reel. Simple. You don't have to touch anything, and export it from here. Export default this particular quick sort. Simple. You don't have to touch any component here. Somewhat down the line, if you want to add any algorithm, just come, write the algorithm, figure out this critical points. How will you figure out the critical points? Again, same method. I'm telling you, you will have to write on your application first. Then first write it on pen and paper like this. These are the steps that I need to record. Not every step is necessary to record, but whatever is a critical step that is getting there's some change happening, major change is happening. Two elements are getting swapped, two elements are getting compared. That you need to store there, right? So in a real format, right? And that you can play like manually or automated, both, whatever you like, right? So that was it. The code, the GitHub, I have posted the code to the GitHub, and the GitHub repo link will be provided. Okay, and so that was it. First of all, you will have to break down the component and write the algorithm there. Take the input, take the speed input, select the algorithm, take the input of the algorithm, whatever algorithm you want to play, and just as easy it is. Believe me, if you are able to figure it out, at which point of time I need to record the state of the array, everything is pretty simple. Okay, so we have already looked at the code. So that was it, and thank you guys, and best of luck.